Good morning, good afternoon, good evening, whatever time you're watching this video. Welcome to Max Makes Maths Easy. Today we are going to do a question on, I think it's circles and its applications. The question reads, the figure below has a cross section of a horizontal cylindrical pipe of center O and radius 24 centimeters. The shaded region represents water in the pipe to a depth of 16 centimeters. The pipe is 12 meters in length. Here we have the circle. The figure below has a cross section of a horizontal cylindrical pipe of center O and radius 24 centimeters. The shaded region represents water in the pipe to a depth of 16 centimeters. This means from this point here to here, it means this is 16 centimeters. 16 centimeters, because we are told the shaded region represents water in the pipe to a depth of 16 centimeters. If here is a 16 centimeters, let's name here N. This means, and let's name here R. This means NR, which is equals to 16 centimeters. Then ON we don't know, so we have to find ON. ON is equals to OR minus NR. OR we know is the same radius. The radius does not change, so OR is 24 centimeters. So ON is equals to OR, which is 24, minus NR, which is 16. 24 minus 16, that is 8 centimeters. So here is 8 centimeters. Remember, these are units. Remember to work with units, so all are centimeters, but we have a 12 meter here. So we ought to change this 12 meters because all our questions are, the first question reads the length of PQ in centimeter, the size of angle POQ. So we want this angle here over here. The second question, the area in centimeters squared of the shaded region. And the third question reads the volume in liters to 1 decimal place of the water in the pipe. So we ought to change these 12 meters into centimeters. So we will say 1 meter is equals to 100 centimeters. I hope you know this conversion. So if 1 meter is equals to 100 centimeters, what about 12 meters? It will be 12 meters times 100 centimeters divided by 1 meter. So meters goes meters. That will be 1,200 centimeters. 1,200 centimeters. So we begin with the first question, the length PQ in centimeters. So we are told to find the length PQ in centimeters. PQ in centimeters. So here we are going to extract this triangle because this side is equal to this side, so this is a half. So we're going to extract one triangle, name it ONQ. ONQ here is 8 centimeters, here is 24 centimeters. So we ought to find NQ using SOHCAHTOA. Using SOHCAHTOA, we will say, if you want to find, we know here this angle over here is 90 degrees. So we ought to say sine is equals to opposite all over hypotenuse. cos is equals to adjacent over hypotenuse, and tangent is equals to opposite over adjacent. So it is a sine theta cos theta and tan theta is equal to. So having that, we will say we'll use, since we know we want to find this side, this one NQ is the adjacent over this angle, adjacent of this angle 90 degrees. So we'll say we'll use cos theta. Cos theta is equals to adjacent all over hypotenuse. So we'll say cos 90 degrees is equals to adjacent, which we don't know. Adjacent, this one we don't know, this one is adjacent, divided by hypotenuse. Hypotenuse is 24 centimeters. So we will say 24 cos 90, 24 cos 90 degrees is equals to adjacent. So 24 cos 90 is equals to adjacent. So we say 24 cos 90 degrees. 24 cos 90 degrees is equal to adjacent. No, not that way. Let me see, cos 90 is cos 90 ought to be cos 90. It's 0. So what are we going to say over here? Let's see another approach. It is 90 degrees. No, we are not going to use a SOHCAHTOA. Since we know this one and this one, we are going to relate with the formula that says a squared plus b squared is equals to c squared. A squared plus b squared is equal to c squared. So a squared, this one is a, this one is a, this one is b, and this one is c. So a squared is equals to c squared minus b squared. So a squared is equals to c squared. C squared is 24 squared minus b squared, which is 8. That is 8 squared. This is 24 squared. 24 squared is equals to 576 minus 8 squared. 8 squared is equals to 64. So 576 minus 64 is equals to 512. A squared is equals to 512. A is equals to the square root of 512, which gives us 22.63. 22.63. And remember, we were told to find the length of a PQ, and we have found the length of NQ to be 22.63. Since I said these triangle and these are same, it's just one big triangle divided into two. So if we find here, it's also the same as here. So PQ is equals to 22.63 times 2. 22.63 times 2, that will be 45.26 is the length. 45.26 centimeters is the length of PQ in centimeters. Here again, the second question reads, first question, second part reads, the size of angle POQ. The size of angle POQ. So we are told to find this angle. We are told to find this angle. We are told to find this angle. So using you can use this. You remember using the sine rule, the cosine rule. But here we are going to use SOHCAHTOA. SOHCAHTOA will apply here. because I had already introduced SOHCAHTOA up here. So we are going to use any to find one of these, and then we will be multiplying by 2. So we will say sine theta is equals to opposite over hypotenuse, and cos theta is equals to adjacent over hypotenuse. So we will say cos theta is equals to adjacent, which is 8, hypotenuse is 24. So cos theta is equals to 8 divided by 24 is equals to 1 over 3. Then our theta will be the cos inverse of a third. The cos inverse of a third is equal to 17.53 degrees. Remember, this is a half here, and we were told the size of angle POQ. So the POQ will be 70.53 times 2. That will be 70.53 times 2 is equals to 141.06 degrees. This is the size of angle POQ. That is the size of angle POQ. We have to confirm with the sine. Sine theta is equals to opposite over hypotenuse. Sine theta is equals to opposite all over hypotenuse. Opposite of this is A, which is 22. We said it's 22.63 divided by hypotenuse, which is 24, and we are saying it is sine theta. So theta is equals to sine inverse over opposite all over hypotenuse. So the sine inverse of the answer is equals to 70.54 degrees. You see, 70.54 degrees is just error in the decimal places, so it's correct. You have seen I have confirmed with the sign, gives us the same answer. Even if you confirm with the tan theta, which is equals to opposite over adjacent, it will give you the same answer as 70.53 or 54 degrees. Let's go into our next question that reads the area in centimeters squared of the shaded region. Remember, the shaded region is a minor sector, the area of a minor sector, and this one is the area of the this one is the major sector, and this one is the minor sector. So we have this one is a segment. This one is a segment. This one is the area of, this one is the sector, minor sector, and this one is the major sector. So this one is a minor segment, this one is a segment. So the area of the segment is equal to area of the segment is equals to area of sector minus area of the sector minus the area of triangle, area of the triangle. So we are going to do the area of the sector. Area of a sector is equals to theta over 360 times pi r squared. Remember, these formulas relates when we want to find the area of a sector is equals to theta over 360 times pi r squared. But when we want to find the length of a sector is equals to theta over 360 times 2 pi r. So area of the triangle, we will use a half a b sine over theta, and the theta we will use here is this theta we found here over here, 141.06. Also, we know other formulas to find the area of a triangle. You can use the Eros formula, we can use the The normal formula we know as it is a half base times height, so we'll use a half AB sine theta. So theta over 360, we are finding the area of a sector. So theta, it will be 141.06 divided by 360 times pi. We were told to use pi as 3.142 times r. Radius is 24, so it's 24 squared. So we are going to key in our values. It will be 141.06 divided by 360 times 3.142 times 24 squared. So we are finding our answer. Area sector is equals to 709.1. So area of our triangle will be a half, we said a half AB times theta. So a half AB sine theta, it means a half AB, this one AB, this one is AB sine theta. So it will be a half AB sine theta. This one will be a half times A times B sine over theta. That one will be 181.01. So our area of the segment is equals to 709.1 minus it will be 0, because we are going to put in 4 significant figures, 1, 2, 3, then 4. So it will be minus 181.0. So 709.1 minus 180.0. This one is 528.1 centimeters squared. That's the area of the shaded region. Then our final question reads: the volume in liters to 1 decimal place of the water in the pipe. So volume is equals to, volume will be, it's always the area. Volume is obvious, area times the length, or we can say surface area times height, or surface area times length. So we were told to find the volume in liters of the water in the pipe. So area of the water in the pipe is 528. So volume will be shaded region multiplied by length, according to our scenario, because the pipe is 12 meters in length, but we said it is 1200 centimeters. So shaded region is equals to 528.1 times length, we said is 1200 centimeters. So we are just multiplying times 1200. That will be 633,720 cubic centimeters. But remember, we were told to find the volume in liters, so we ought to know 1 liter is equals to 1,000 cubic centimeters. So what about 633,720 centimeters cubed? So it is equals to 633,720 divided by 1,000 divided by 1,000. So our answer, then we divide by 1,000. So it will be 633.72 liters. But remember, we were told the volume in liters to 1 decimal place, so it will be, our answer will be 633.7 liters. 633. So our answer goes to 633.7 liters. I hope you have followed through from the beginning. Remember, in maths you learn to follow instructions, so you are told to take pi is equals to 3.14. Remember, another question can say take pi to be 22/7, but here we were told to use pi as 3.142. 3.142. 3.142. Yes, 3.142. So that's our question today. Thank you very much for following, and welcome to Max Makes Maths Easy.